In a class B power amplifier, output is dash of the input full cycle. Okay. If we see the power amplifier, generally we have four type of power amplifier. Class A amplifier, class B amplifier, class C amplifier, and class A B amplifier. So we have four type of amplifier: class A amplifier, class B amplifier, class C, and class AB amplifier. If we talk about output waveform in a class A amplifier, output waveform will be the full of input waveform, full of input cycle, input full cycle. Okay, input cycle. And in class B it will be the half of input waveform. Okay, in class C it will be the less than half cycle of input, and in class AB it is more than half but less than full of input cycle. Okay, this 4 point you need to remember anything they will ask in exam. Okay, in a class A full, it will come full output. In output full wave come for a input cycle, and class B half waveform will come. In class C less than half waveform come, and in class AB more than half but less than full waveform will be come. Okay, so according to this we can say about conduction angle of amplifier. In class A amplifier it is a full waveform they will give in output, so here the conduction waveform will be how much? 360 degree. And class B is a half waveform, means 180 degree. And class C less than half means less than 180 degree. And class AB is more than half but less than full, means the conduction angle will lie between 180 degree to 360 degree. Okay, this thing also you need to remember about conduction angle of amplifier. And sometime they will ask also one more thing: efficiency of amplifier. So in a class A amplifier, efficiency will be your 25% to 50%. In class B it will be 78.5%, and class C it is less than 50%, and in class AB it will be 50% to 78%. Okay, so whatever is there in this table, they may ask any kind of question. Like in a class A, what is the conduction angle? So it is 360 degree. Okay, what is the efficiency of class B amplifier? So it is 78.5%. So like that they will make question. Okay, so whatever I am going to explain, that thing you have to remember, that you need to note down. From that also question will be come. Okay, next question. A transformer is a dash device. Generally devices, we have two kind of devices. Generally we will divide devices in a two part. One is active and another one is passive device. Okay, active device means what? Active device means which required external power to operate. Okay, external power to operate. And in passive, no external power required, no external power required to operate. Okay, so active devices means who? Active devices means what? Like LEDs, then diode, then transistor, amplifier. These are the example of active devices. In passive devices are C, and transformer. Okay, resistor, inductance, capacitor, and transformer are what? Passive element or passive device. So here transformer is a passive device. Option B will be the right answer. Okay. Frequency in UHF range propagate by means of UHF means ultra high frequency. Okay. So if we see about ground wave, in ground wave generally frequency will be in ground wave generally frequency will be low frequency, in a range of low frequency, or very low frequency, and medium frequency we are using in a ground wave. If we see the range for ground wave, then the range will be around 3 range will be around, just a second, so range will be around 3 kilohertz, 3 kilohertz to 300 kilohertz. Okay. And skywave we are using high frequency. Skywave we are using high frequency, that is the range of 300 kilohertz to 300 megahertz. Okay. And space wave we are using very high frequency. This is very high frequency, then ultra high frequency, and super high frequency. Okay, in the range of 300 megahertz to 3000 gigahertz. Okay, so like that you have to remember every point. Okay, so here UHF means ultra high frequency, so answer will be space wave. So these all points you have to remember. What is the range of high frequency? They will ask question. You have to answer 300 kilohertz to 300 megahertz. Which frequency we are using in ground wave? So we are using low frequency, very low frequency, medium frequency. This is the answer. So like that question will be come. For a given circuit, the forward resistance of PN junction is 50 ohm and the reverse resistance is infinity. Then circuit following through 100 ohm resistor is what? Okay. So what they told, for a given circuit, the forward resistance of PN junction is 50 ohm. Forward junction is what? Forward junction is 50 ohm. Okay. Forward PN junction means this one is a forward bias, so this is what? 50 ohm resistance. Okay, and the reverse diode is infinity. This one is infinity means it will act as a open circuit. So we can redraw this circuit as a like this. We can change this one in resistance, and we can make this circuit again. Infinity means open circuit, and this will be like this. Here 6-volt battery, one resistor, and this is the circuit diagram. This is how much? 50 ohm. This is 150 ohm. This is again 150 ohm, and this is 100 ohm, and this is 6 volt. Okay, so now we can redraw this circuit again like this. This is open circuit, so current will be here. This is open circuit, so no, not required this one, because current will not flow here. So we can remove that one. This is 100 ohm. This is 6 volt. This is 50 volt, 50 ohm, and this is 150 ohm. Okay. So now we have to found the current flowing through 100 ohm resistance. So we can put here what? KVL. So KVL we will apply here. KVL. So if we apply, this is plus, this is minus, this is plus, this is minus, plus, minus, this is plus and minus. So we have to go like this. Okay. So whatever, like if you are choosing this plus position means outgoing, so it will be 6 volt minus, this is what? I means 50I. Okay. Again minus 150I and minus 100I equal to 0. Like this we can write from KVL. Okay, so 6 volt is what? Minus 50, this is the 100, 150 and 50 is around 300I. Okay, equal to 0. And 6 volt equal to, we can write 300 I, and I equal to what? I equal to 6 by 300. That is what? That is 2 by 100. And we can write this one 0.02 ampere. Option B is the right answer. Okay. Next. It here I gave the answer. Oh, here first is a half. Okay. Option B is the right answer in first question. Now 4 is okay. Now fifth question. A 240 kilohertz 10 VPP carrier is amplitude modulated using 1 kilohertz sine wave of 3 VPP. What is the modulation index? Modulation index is what? Modulation index is generally we are denote with U. Mu equal to AM by AC. AM is what? AM is a peak to peak voltage, that is VPP, peak to peak voltage of message signal. Message signal. Okay. And this is what? AC is what? AC is again peak to peak voltage of carrier signal. Carrier signal. Okay. So here what we have, here we have VPP, 10 VPP carrier signal. So AC we have peak to peak voltage of carrier signal is what? 10 volt, and this is amplitude modulated using 1 kilohertz sine wave. Amplitude modulated means message signal we have given 3 VPP, 3 volt we can say. So we can put this one here. This is 3 by 10, that is equal to what? 0.3. So 0.3 is your answer, option B. Okay. Now one more thing you should remember here. They will ask some question like this. When condition they will give, when mu is means modulation index is less than 1, then it is called under modulation. Okay, under modulation. When mu is equal to 1, then it is called perfect modulation, and mu is greater than 1, then it is called over modulation. Over modulation. So this 3 point you need to remember. Okay, they will ask sometime like if modulation index is 1, then what kind of modulation it is. So you have to answer perfect modulation. Like this you have to remember. Okay, the phase shift between input and output of an emitter follower is, generally we have transistor configuration. So generally we have three type of transistor configuration: common emitter configuration, common base configuration, and common collector configuration. This common collector is also called as a emitter follower, emitter follower circuit. Okay, this is also called common collector, is also called emitter follower circuit. Now if we talk for phase shift between input and output, then in C common emitter it will be 180 degree, in common base it is 0 degree, and in common collector, that is emitter follower, it is 0 degree phase shift. Okay, so here our answer will be what? Phase shift between input and output of emitter follower means collector, common collector, so 0 degree. Option A is the right answer. Sometime they will ask about power gain. What is the power gain of common emitter? So it is high. Okay, it is high. Common base is moderate, and common collector have low power gain. Like this you need to remember the point. Okay, now diodes which are used in voltage regulator are, in voltage regulator, what kind of diode we are using? Zener diode we are using in a voltage regulator. When, in which condition? When it is in breakdown region. Breakdown region. When Zener diode is in breakdown region, then it is used as a voltage regulation application. Okay. Now, input and output quantities in field effect transistor are nonlinear related due to square term is what? Shockley equation. Shockley equation, what is this? Shockley equation gives current equation, current equation of field effect transistor. That is what? ID equal to IDSS 1 minus VGS by VP whole square. Okay, where ID is what? ID is your drain current, drain current. IDSS is what? IDSS is drain to source current. Then VGS is what? VGS is your gate to source voltage. Okay, and then VP is what? VP is called pinch pinch of voltage. Okay, this formula you need to remember. This is Shockley equation. Okay, Shockley equation formula. Now we have to simplify these things. This is what Boolean algebra, this question is from digital. So I think you know about Boolean algebra. So this is B plus C. Now what we will do? We can write this thing AB plus this one. We can write AB plus AC, and here we can write BB plus BC. Okay. Now this thing AB and AB. Generally this A plus A is what? A plus A is what? A plus A is A. So we can write this AB plus AB as a AB plus this is what? A B dot B. So A dot A is what? A dot A is A. So we can write this one again B dot B as a only B. Then plus BC. Okay. Now this is AB plus AC, and from here we can take B common and we can write 1 plus C. Now again 1 plus A is what? 1 plus A is 1. Okay. So these all are the this is Boolean equation. Okay, these things are Boolean formula you can say. So we can write this thing AB plus AC and plus this is 1, A plus C become 1. So because A plus 1 plus A is 1 means 1 plus anything is 1. So this is B. Okay. Now again if you take common from this thing, if we take common B, then we can write A plus 1 and this is what? AC. Okay. Again this thing what? 1. So this is B plus AC and this is the answer. Option B is right answer. Like this you need to solve the question. Okay. A series RLC circuit supplied by 220 volt AC voltage has R is 10 ohm, L is 10 Henry and C equal to 1 microfarad. Find the quality factor of an inductor at resonance circuit. Okay, so quality factor is what? Quality factor is frequency by bandwidth. Okay, quality factor is what? Frequency by bandwidth, and we can write this thing. Quality factor is what? In quality factor for resonance circuit is what? 1 by R under root L by C. Okay, so everything we have 1 by R we know 10 ohm, L we know how much? 10 millihenry. So 10 into 10 to the power minus 3, and capacitor is 1 microfarad, that is 1 into 10 to the power minus 6. Now we need to solve this one. 1 by 10, this is we can write 10 into 10 to the power minus 3 and into 10 to the power 6. Like this we can write, and again this is 1 by 10, and this will become 10 into 10 3, or this is 1 by 10, we can write 10000. Okay, 40, and this is 1 by 10 under root, so it will come 100. This gone, so this is 10. Option A is the right answer. Okay, next, Siemens is the SI unit of dash. Siemens is the SI unit of what? Conduction. Siemens is the SI unit of conduction. and we can denote Siemens. This is conduction is G, and Siemens means what? Like this symbol will be there for Siemens. Conductivity, if we talk about conductivity what? Conductivity we can denote like this, and SI unit of conductivity is SI unit is what? Siemens. SI unit is what? SI unit is Siemens per meter. Siemens per meter. Okay, and resistivity is what? Rho. Resistivity, if we see SI unit of resistivity is what? Ohm meter. Okay, ohm meter. And resistance is R. RSI unit is what? Ohm. Everyone knows this thing, ohm. Okay, so here option B is the right answer. The phase modulation and amplitude modulation are considered as a special case of dash. So we have digital to digital to analog modulation scheme. So we have three digital to analog modulation scheme: FSK, PSK, FSK, PSK, and ASK. ASK. Okay. FSK, PSK, and ASK. Frequency shifting, phase shifting, and amplitude shifting. Okay. And we have one thing, QAM, quadrature amplitude modulation. Here in quadrature amplitude modulation, it will take phase and amplitude both. Okay, so that's why here the phase modulation and amplitude modulation are considered as a quadrature amplitude modulation. Okay, in the below circuit the number of branches and nodes are. So branches means what? Branches means number of element. So this is one element, this is another one, this is another one, this is another one, this is another one. So total 1 2 3 4 and 5. 5 elements is there, means 5 branches there. And node means what? Node where two and more element are connected. Like if you see this voltage and this resistance is connected here, so this is one node. Here this resistance and this resistance is connected, so this is another node. And here this voltage and this resistance is connected, so this is another node. And this much node is there, three nodes. So 3. Option A is the right answer. 5 branches and 3 nodes. Okay. Which of the following gate can be used as a priority generation? Okay. So if we talk about logic gates, we have three type of logic gates. Okay. What are the three type of logic gates? I know you will say and or not. Okay. But that is another thing. Three type of logic gates are: one is basic gates, another one is universal gate, and the third one exclusive gate. So this is the three type of logic gates. In basic gate we are studying AND gate, OR gate, and NOT gate. Okay, three type of basic gates are there: AND, OR, and NOT. And universal gates are NAND and NOR. Okay, two gates are there, NAND and NOR. Exclusive gate is XOR, and XNOR. Okay, these are the gates. This is also written as XOR and XNOR. Like that, we can also write this gate. So this exclusive gates is used as a priority generation and checking. So option C is the right answer. Okay. Find the minimum number of NAND gate required to realize a XOR gate. Okay, so I will teach you one thing, one table. Just remember this table. This is what? This is NAND, and this is NOR. Okay, just remember this table, it will help you for every exam. This is NOT, then AND, this is OR, XOR, and XNOR. Okay, so if this is 1 and 1, okay, this is 2, this is 3, again cross this one, 3 and 2, this is 4, this is 5, again cross this one, this is 5 and this is 4. So whenever question came anything, it will come. Like here they ask, find the minimum number of NAND gate required to realize XOR gate. Realize what? XOR gate. So XOR gate, this one is XOR gate using NAND gate. Using NAND gate, how much required? 4 required. So 4 is the answer. If they will ask using NAND gate, realize OR gate, how many NAND gate required to realize an OR gate? So OR gate, 3 gate will be required. Answer will be 3. If they will ask how many NOR gate required to make AND gate, so this is again 3 answer. Like this you have to give answer. So remember this table for realization of any gate. Okay, so now 16 for an AND channel. One more thing here, why universal gate? NAND and NOR gate is why universal gate, because using NAND or NOR gate we can make any kind of these gates. Okay, any basic gate we can make, and exclusive we can make. So that's why NAND and NOR are a universal gate. For an N channel enhancement MOSFET, ID increases when? So two condition is there for enhancement MOSFET. EMOS, we can say enhancement MOSFET. When VGS is greater than VT, means gate to source voltage is greater than threshold voltage, then ID will increase, or ID increases, or we can say ID is greater than 0. In this case, MOSFET is in on condition. Okay, on condition, and VGS is less than VT, then ID decreases, or we can say ID is less than 0. So in this case, MOSFET is off condition. Okay, so question will come like this, means what is the in following which one is the MOSFET in on condition? So you have to give answer VGS is greater than VT. Okay. Like this you need to remember. So here they ask ID increases. ID increases means drain current is increases. Drain current increases, in which case VGS is greater than VT. Option A is the right answer. Okay. Clamper is also known as. Clamper circuit is what? Clamper circuit is generally it will clamp the DC voltage without changing input, without changing applied input signal. So generally it will clamp the DC level. So we can say DC restore to a clamper circuit. Okay, so option D is the right answer. Which of the following is not the correct representation of power? So here if you see, this is the power formula, this is also power formula, this is also power formula, but this one is not a power formula. So our answer will be option D is the right answer. Okay, so we have this kind of this is the power formula. You have to remember power formula like this. One more is there, I square R, P equal to I square R. The unit of power is what? The unit of power is watt. Okay, SI unit is what? Watt. So this much only. In TV broadcasting, video signal are transmitted in dash and audio signal in transmitted in dash. Okay. So for video signal we are using AM, and for audio signal we are using FM. Option A is the right answer. Amplitude modulation we are using for video signal, and for audio signal we are using frequency modulation. One more question is there, like in uh, 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 in television, which modulation scheme is used? Which modulation scheme is used? So this will be VSV. VSV. Okay. Digital sideband sideband modulation. Okay, correct. VSB. So this is the answer for this thing. Okay. Next question. So this is the last question. Just answer this question and give answer in your comment box. Okay. This is you can expect in your exams. Okay. So like this question, you need to prepare, and whatever I am explaining you in your solution, that you need to make a notes. From there, you can find some more question. So like this, who have taken this PDF sets of question PDF, so they have to more focus on a detailed solution. Whatever solution I gave, from there you try to make a question. Like this question you will expect in your exam. Okay. And those who haven't buy till now this 5 set of PDFs, just take this PDF set. Here you will get exam pattern based question. So if you complete this one, around 500 question, 500 plus question you are going to complete. That will be helpful for your exam. Okay. So those who want, just message me, WhatsApp me in this number, and you will get this PDF. Okay. Till then, if you like this video, just hit like on a video and kindly share with your friends. And if you're not subscribed my channel, just subscribe the channel and wish you happy new year to all. Thank you.